Hello, my name is Jakub, and I'm very stressed, of course. Be- no. But it's not about the talk that I'm stressed. It's just I lately was made redundant in a company as a software engineer, and I had to kind of downgrade my standard of living. So this is my new flatmate, and we live just next to the petrol station where I actually got a good job as a counter salesman. So over there, I have a manager who found out that I have a career behind me, and he sometimes just nags me on the chat. Things like I had a dream, and I'm like, he sees things, and he's really symbolic. So then when I hear something like that, I immediately think on the behind the counter, okay, is that pump working in a separate thread or in the fiber or something? But he keeps on pushing. Like, I want to know which pumps we should buy and how many. And how much fuel we need to order depending on traffic. I already have 9 ideas, but they all seem equally awesome. Could you compare them for me somehow? I'll definitely need some nice animations and data. And when we hear about animations, we are all happy as backend developers, especially in Ruby, because our framework just is supportive a lot about animations, no? So, but I could take it easy. We had a whole day for it. So that was good. It was 3 a.m. Uh, and yeah, I thought, okay, why not doing it? What better thing I have to do? So sometime later, I show him this. Hey, dude, I have a simulation for you. And I was very happy about showing him that it is visualized, no? And look at that. I'm showing him, and he's like, "What is this? Some biology joke, or where are the cars?" So I'm telling him, "Look, this is a petrol station around, and in that big bubble, there are cars waiting in a queue, which are the ones that are outside the orange bubble, which is about the cars being pumped, or the green bubble about the cars that already are fully fueled." So I further described to him that you look, there are cars served because of cars not served because of lack of fuel in the black box, and the partial ones in the brown. But he was not convinced. Definitely, this is not how his dream was. But then I wanted to show him that look, it moves, so you can see that something is happening on the petrol station. No, these things are actually alive. You just need to understand my concept. But he didn't want to understand my concept. But I show him, look, you can do 2 simulations at the same time and compare your parameters for the petrol station and see which one do you like more. Is this one working better as a station, or the other one is working better as a station? And then I say you can even compare all your 9 or 8 ideas and see them in parallel, and then have your ideas, which one is the best for you. And from my perspective on this, like, the best were the simulation number 2 and simulation number 5, because they had the most cars fully fueled in the green circles. So I show him this, but he was not very much interested. So, but let's compare these 2 ideas. Like, in the first one, we have 3 pumps of 3 seconds per liter, so there are faster pumps. And in the other simulation, we have 6 pumps at the rate of 6 seconds. So sometime later, I show him this. Look, there are actually cars coming to the station. There's a top station and a bottom station. They all have price tag on their fuel. And you can see some data, like, the revenue and all that. So maybe now you're happy, okay? Because you see the cars that you didn't see in the previous one. But he says, wait, I saw the spreadsheets, simulate for, oh, what is this? I don't think it. So he said, the revenue is better for simulation 8 and 7. I want 8 and 7, not 5 and 2. And the fueling time is better in these. and the fueling speed is better. The waiting time is less in the queue. So I gave him finally the simulation 7 and 8. So he can again see the cars coming, they're being pumped, some are waiting in the queue, the revenue comes up as the cars leave the station. And yeah, true to him, the best simulation was number 8 with the best revenue. Yeah. So he says, this is it, we have a green light, you can go to Sarajevo. So I said, all right. So how does it work? Let's see some of that. Like, the concept is that we have some scenarios written in a YAML. We put it through a config runner, and for each simulation we inject both logger, timer, and a global report. And then this works through a simulation runner, and we come to an end. In a single simulation, we have a station that has many pumps. These pumps are consuming the queue to which a car spawner is pushing the cars, or the car spawner pushes cars to the ASCII road as we saw it, because then the queuing is different depending on the board actually. So the queue also pushes some updates to the report. We have a separate thread for a report saver, and this way we get the data in a JSON, for example, that can be read again from some server to display these D3JS graphs. And the ASCII art is like this, that there's a board that animates and refreshes the screen, and inside of a road object we have all those roadies, which are the cars that have their positions, and at the end we get a pretty nice effect that you can stare at as a screensaver if you want, and be happy. So some components. Let's first look at the logger, the most basic and needed component, and this is actually how this mini project of hobby started for me. So you run and you see that in some moment in time that is done by the timer, there are some simulation parameters at the beginning and the things that happens, the events that happen, no? And the results at the end. My first thought with the simulator was, how should I position the pumps, what parameters the pump should have so the cars wait the least amount of seconds. And from that idea, the rest kind of came up, the hobby thing. So now let's look at the timer. So I'll show you some counter-based timer. Hear something?
Nyilván minden turistának eszébe jut, hogy itt...
Some previous ideas on an Arduino things that I was doing a washing machine with my uncle actually, but you can see some similarities from my kind of previous mental imprints about simulators, that you want to do something that you see in the graphics, but it's happening on an LED, for example, and they seem like they need to work in different threads. But actually with Arduino code, you just have one big loop, and you need a lot of arrays in which you put like when particular output should be low or up, no, or high. And as you see there, the delay is 1000, and that means that we just cycle, every second we make a change. So these are two people that inspired me to do stuff. You can see that the picture is old because of how laptops were air thin. So they are my kind of guides on the programming journey that I had 20 years. The middle is my dad. Here's my uncle, and that's my friend from work, Jorge. So let's go and see how timer can be done inside of Ruby. This is a basic class of timer. So you can see there's a thread, and in that thread we wait particular time, and then we tick. And something I would say about JRuby, MRI, and Gil over here. I tried to do that in JRuby, but with JRuby, if you run that code, the thread can get a separate parallel, CPU even, and just run that thread very fast and tick super fast, so that the other threads, they cannot keep up with it. And with the MRI, if you have if you have guild, they all have to keep up some way. So that's how it better works with MRI. So we basically update current tick as the step that we have. The normal step would be just one. We wait the duration, and the duration is dependent on the speed of the simulation that we can config in our YAML at the beginning. There's also a helpful function if you do simulations that are called from stuff like car, spawner, station, or pump, is that you wait for a particular tick of the timer so that you can make some action. And this basically waits until the tick has come and then does things. Okay, so let's look further in the structure, how this simulation YAML can look, how we can think about configuring our scenarios for simulations. How does the simulation, in the very basic way, look like, and in the simulation runner. So that's the YAML. As you can see, you define speed, you define car numbers, car's number that will come to the station, the fuel station reserve, the station closing tick, like how many pumps you have, what's the speed range of this pump, how much the fuel cost, and what's its price, so that you can calculate the initial cost and the revenue at the end. And then you define the scenarios. So for my manager, I defined the scenarios that had 2 simulations in it, and they were just overriding some default settings in order to meet his expectations. Then you run such a YAML file, not maybe directly here, but just an approximate. You have a runner. First 2 simulations from the scenario box you can display in the ASCII art if you want, and the rest of them you just run directly in a simulation. And I used async here just to also show that I used interchangeably threads and async. I use async for more top level things like dispatching simulations or making refreshments in the ASCII board. But I use threads for CPU heavy lifting, like pumping cars and so on, and threads are good for that. This is how the simulation kind of main method works, that you just calculate how long it's going to take, you start the timer, you put some intro, outro, and you join all the threads, which are like station thread, queue thread, car spawner, road, and report saver. And you can see here that it's not that every car has its own thread. That's not needed. I know that sometimes I like to think about such simulations that every car is like a living entity and they deserve their own thread, but they don't. You just need a car spawner that pushes to a queue and the queue consumer, and that's it. So let's take a look at the car spawner then. I did something like this random interval enumerator that spawns them and pushes them either to the road if you do ASCII art, or just directly to the queue if you don't care about the visuals and you just want the logger to give you an idea. And this random interval enumerator, like you define the car's number that you want, and you just check if the station is done, if it's not closed, and so on. And this car's delay interval range is also defined in the config file. So you pause for as long as you define it there, and then you yield a new builded car and you push it to the queue. So if you define this delay interval range between 2 and 8 units of time, it's going to push in that kind of ratio. I've run this simulator, like you can run much more than 10 simulators with a lot of cars, and it doesn't have much problem with the CPU load, because if you increase the number of cars, it does not increase number of threads. thanks to such a lazy enumerator. And as I said, better not pre-build all cars in memory, because that's not gonna, the program's not gonna run even if you put that amount. And better not make thread for each other. And this is a very sweet slide, and I think I can put something more over here. And yes. So, as I said about the ASCII art before, so how do we even think about ASCII art sometimes? No? Let's look at the board. This is how you define a board in Ruby. So as you see, it's just a constant string. And what you saw before was moving, and this is not moving. You can see placeholders like the X's for the top petrol station and Y's for the bottom. And on the right hand side you see, oh sorry, this is the station part. But here on this one you see all the placeholders for actual data that you want to display to the user, so he can see or she can see what's happening. And then we can look in the queue. How does the queuing of the cars work in some basic way? But here I'll ask you a question. Who ever directly and intentionally used condition variable? Wow. Like, no hand. That's what I thought, actually. So with condition variable, you can do something like easy producer and consumer example in Ruby. Look at that. I will not build much theory about the idea of mutex here and so on. So if somebody is completely not into mutexes, then in the resources I show where's the best start reading about them. But in this example, you can see that we are protecting in the mutex something that is putting stuff in the queue. And then after that, we are signaling by the condition variable to another threads. These are producers. We are producing cars here, and they have random time into coming to the queue, to the station. And now we have consumers, and these are the pumps. And as you see, there's a lock, the same lock, but it waits until the queue is not empty. And if it is empty, it will put that thread into sleep. And therefore, it will unlock the mutex. And if the producer is going to signal, then we can go further with that thread. And it will eventually take stuff from the queue and do the rest, which is the sleep fueling time or some other calculation. And the result would look like this. That there are cars coming, the pump is taking them, and when all pumps are busy, the car 3 is first in the queue, then the 4th is coming, 5th is coming, and then the car 1 is pumped, so the pump 1 is free, and it takes car 3. So condition variable also has another method, which is called broadcasting, so it doesn't just signal to the first registered thread, but it broadcasts the idea to all of them. All right, so we are approaching a summary of that talk. Some lessons learned. This is definitely a book to read. This is how this whole simulator is built, basically. I just, you play around with the idea that for me started because I like the smell of petrol. And you just pursue that dream, right? A few funny things, I would say. It's very hard to find out how many petrol stations there are in Sarajevo, for example. These kind of data resources are usually paid, and then they are very hard to find. So one thing you can do is go through Google Maps and check it out, or you can take vacation in Sarajevo and you drive with somebody who at least will tell you that there are 200,000 cars in Sarajevo, you know, a taxi driver. But he couldn't answer me how many petrol stations there are. So, but some approximates are around 200. The lessons learned. If you do stuff like this, do dependency injection from the beginning. I started with making a timer and the logger the only instance singleton for a whole project. Why not, right? At least there is one thing that should write to the log and one timer to rule them all. But no. So always think forward, because then you'll need to rewrite. So dependency injection, good. Then system time flies. That means it cannot give you that much control. If I would base my timer on some, epoch till the nanosecond, it doesn't give me that much control as if I do my own counter. And sometimes GIL is what keeps you going, but then you need to be aware that your code works well because of it. So you need to think differently if you want to make it really parallel. Forget about tests when you're making a prototype, because they will expire very fast. So just play along. Hobby projects makes your production code better. You need to make your tiny little funny decisions there, and then naturally you're going to bring them to job. Do things with Ruby that you wouldn't do at all at your job. So, and this is a programmer smile when cutting simulators. I actually found myself being so immersed in that I thought, oh shit, how my face is going to look like. So I make a picture and I say, okay, this is a good sign that I enjoy what I do. And as my friend always said, that my forehead is like an airport, so I made this for him. And follow-up ideas, maybe some framework or gem for such simulations, something that if somebody comes up with they can reuse what I did. Wrap simulators and reactors, because these simulators, they can actually run in parallel. Why not? It's just inside, they need that kind of GIL factor. I would like to play with the idea in other languages like Go and Elixir, because they're more maybe made for it. Just like we saw yesterday with this live view, that would look nice. Make the internals event-driven. They are not event-driven right now. It's more like the one talks to this one and the other to this one. Make a game from it with different boards and levels. WASM it up. That would be interesting to just see it working in a browser with that WASM compiler that we saw. Or just leave it as it is and forget. And so these are the resources. If you're going to find this presentation somewhere, I say again, the workingwithruby.com, WWRT. It's an old article about working with Ruby threads, but it's still a very good intro, well thought through. And music in the videos, there was no music as far, but maybe you will hear some soon. I also want to thank to the PL Rug Ruby Warsaw meetup for letting me presenting that around April, where I just had a logger back then, and I kind of sent it here, and they liked it also. So I made this visualized. I'm very glad for the visuality to do that in Poland. So I want to thank you, and at the end show you something. And please see that the top and bottom simulations are working with different timers. This is cool. Look at that. You see, you can do stuff simultaneously with different settings completely. This is simulation speed 20. And this is simulation speed 1000. And you can put as many cars as you want, and they're gonna get pumped and pumped and pumped. Yeah. And you just check the revenue, and the revenue grows up. So it's just amazing. All right. I hope you enjoyed that. Thank you again.